So in my last reel, I asked you a question. How is it the battery is able to push the charges across a distance, as in the battery's push is what we call the voltage? Then how is the voltage not applied across the connecting wires, but the voltage, potential drop, acts on a distance, like acts on the resistance, the appliance, which is a bit farther away, right? Okay, let's explore the answers now. For the sake of simplicity, we will consider conventional current, which means the positive charges are the ones which are flowing. All right. So I'm assuming the positive charges are flowing in this circuit. The moment the switch is turned on, right, at that instant when the switch is just turned on, the wires are empty and the battery is eager to push the positive charges out of itself into the wire. So what will happen? There's going to be a huge ejection of positive charges. They will flow down this wire. And a huge number of them are going to flow down because battery is very eager to get them out of the way. What then happens is there's going to be a high current in the connecting wire, right? But then we come here, and here we have a resistor. It is like I'm entering from a 12-lane highway into a village lane, a very thin, crowded lane. What's going to happen? Of course, traffic jam. So we have a traffic jam, literal traffic jam here. The resistance applies a high obstruction to the positive charges. So the positive charges are not able to get in with equal rate. So what happens? Some positive charges are accumulated here. They are still waiting to get in, right? Here, the moment the positive charges are like out of the resistor, they have again a 12-lane highway open in front of them. They'll just zoom out. There will here be a paucity of positive charges. Let's call this a negative charge. So what's going to happen? Now here the current is low because current is low inside a resistor because there is obviously a lot of resistance, right? Very few electrons can go by and there's a traffic jam, right? But slowly, firstly, this itself might seem a bit controversial because you will say, but we have always studied that the current is same throughout the circuit. Know that what we have studied is a steady state current. Okay, this is a transient phase. The instant the switch is just turned on. So it's only a transient state. We don't talk about this in the textbooks or a regular class. Okay, what we have studied still holds true, but that holds true for a steady state. Once the current has settled down, this is just the moment when the switch is just turned on. All right. So now we have a lot of negative charges here, right? Positives here. What will happen? Obviously, the negative charges are going to attract the positive charges, right? On the same note, here we have a lot of like an accumulation of positive charges. Will they be welcoming towards these new charges? Of course not. They'll be like, there's so much crowd here. Just, stay where you are. They're gonna have a repulsion. They're gonna repel these incoming positive charges, right? So slowly, and when I'm saying slowly, this is like, slowly in terms of this steady state, okay? Not really slowly. This happens almost instantaneously. But yeah, after some time, this current will like decrease. right? Because it is the incoming charges are being repelled by this accumulation of positive charges. On the same note, this current, which is low, will now steadily increase because these are being pulled down by this negative charges. Low, but increases. Over a period of time, this continues to happen until this current, the high current and the low current, they both become equal. And that is what you call the steady state. This is what you have studied. The current stays equal throughout the circuit, right? That's one. Two, your question was, why isn't the voltage drop happening across the conductor? Well, because of this charge accumulation, which results in this potential of this end and this end becoming equal. That is why there is no potential drop across the connecting wire. Similarly, the question that we posed last drill was, how can the battery apply a force across some distance, not across the connecting wires, but across some distance on the resistor? It's not the battery which is doing that. This is these charges. These charges are what are pushing the charge carriers down, the positive charges down, right? So the potential, the push that the resistor experiences is not because of the battery, it is because of these charge accumulations. So that's the answer to that question. I am Pragya, helping you think physics, not memorize it. Bye bye.